You throw a cold bowl of leftover pasta into that little metal box, punch a few numbers, and 2 minutes later it is perfectly steaming hot. Yet the plastic bowl it is sitting in is completely cold to the touch. Then, out of pure laziness, you leave a tiny metal fork resting on the plate. Suddenly, it looks like a miniature lightning storm is violently erupting right in your kitchen, and you are terrified the whole house is going to burn down. For decades, this trusty appliance has been the absolute savior of quick dinners, busy mornings, and late-night snacks. We rely on it constantly, but we also live in absolute fear of it. We are strictly warned from a very young age to never ever put a piece of aluminum foil or a metal spoon inside, otherwise absolute disaster strikes. But how does this magical box actually heat up our food so insanely fast from the inside out without using a hot flame or a glowing metal coil? And why exactly does a tiny piece of metal turn a harmless kitchen gadget into an aggressive, spark-throwing monster? Today we are going to look behind the heavy glass door, break down exactly how a microwave oven works step by step, and discover the explosive physics of metal so you can finally stop fearing your favorite kitchen appliance and understand the brilliant engineering sitting on your countertop. To understand the magic, we have to start with the absolute heart of the machine, a heavy, highly complex hidden component called the magnetron. The technology behind the magnetron actually dates all the way back to World War II, when it was originally developed to power military radar systems. It was only after a scientist accidentally melted a candy bar in his pocket while standing next to a radar array that the cooking potential was discovered. Unlike a traditional oven that slowly heats up the air around your food using glowing red coils, a microwave oven uses invisible electromagnetic energy. When you plug the machine into your wall and hit the start button, standard household electricity flows directly into a high-voltage transformer, which steps up the power and feeds it straight into the magnetron. This brilliant little device takes that electricity and transforms it into high-powered radio waves. Yes, you heard that right. They are just radio waves, specifically operating at a frequency of 2.45 GHz. These are the exact same type of invisible waves that carry Wi-Fi signals to your smartphone or laptop, just concentrated at a much higher power level. Once the magnetron generates these waves, it blasts them through a short metal tube called a waveguide, channeling them directly into the main cooking chamber where your cold food is sitting. But how do invisible radio waves actually make a cold slice of pizza hot? It all comes down to the microscopic water molecules hiding inside almost everything we eat. A water molecule is incredibly unique because it is asymmetrical, meaning it has a positive electrical charge on one side and a negative electrical charge on the other side, acting exactly like a tiny microscopic magnet. When those concentrated microwaves flood into the cooking chamber, they create a rapidly changing magnetic field that reverses itself billions of times every single second. As this magnetic field violently flips back and forth, those tiny water molecules trapped inside your food are forced to frantically flip back and forth with it, constantly trying to stay aligned with the shifting field. Imagine a massive stadium full of billions of people violently shaking and spinning around in their seats at lightning speed. All of this chaotic, microscopic movement creates a massive amount of physical friction, and as we all know from rubbing our hands together on a freezing cold day, friction creates pure heat. This intense molecular friction is what instantly heats up your food. Because the waves penetrate the food directly, it cooks incredibly fast compared to a regular oven that just slowly warms the outside crust first. And because dry materials like glass, ceramics, and most plastics do not contain trapped water molecules, the microwaves simply pass right through them without causing any friction, which is exactly why your bowl stays cool while the soup inside gets boiling hot. You might have also wondered why the glass plate inside always rotates. Because microwaves bounce around the metal chamber, they cross over each other and create standing waves. This means there are certain spots in the microwave where the energy is incredibly intense, and other spots where there is almost zero energy at all. If your food just sat perfectly still, you would end up with freezing cold spots right next to burning hot spots. The spinning turntable constantly moves your food through the intense energy peaks and the dead zones, ensuring an even, perfectly cooked meal every single time. Now, this brings us to the most famous, terrifying rule of the kitchen. Why does metal cause such a violent, sparking disaster? To understand this, you need to know how metal reacts to those exact same invisible radio waves. Metal is a fantastic conductor of electricity, meaning its atomic structure is absolutely packed with free-flowing electrons that can move around very easily. When the microwaves hit a piece of solid metal, like the flat, smooth metal walls on the inside of the microwave oven itself, the waves literally just bounce off the metal like light bouncing off a bathroom mirror. This is intentionally designed so the waves ricochet around the chamber, bouncing off the walls, the ceiling, and the floor, hitting your food from every possible angle. A thick, smooth, completely flat piece of metal like a heavy baking sheet actually would not cause any sparks at all. It would just reflect the waves and block your food from getting cooked. The real catastrophic danger comes from thin metal with sharp edges, like the pointy tines of a fork, crumpled up aluminum foil, or the decorative gold trim on a fancy vintage teacup. When the microwaves hit those sharp, thin, or crumpled metal edges, they act like an antenna, pushing all those free-flowing electrons into the very tips and sharp corners of the metal object. Because the metal is so incredibly thin and the edges are so sharp, the electrons have absolutely nowhere else to go, and they get crowded together at dangerously high voltages. The electrical pressure builds up so intensely that it actually rips electrons right out of the metal itself and shoots them through the surrounding air. When high voltage electricity physically jumps through the air like that, it superheats the oxygen and nitrogen molecules in the atmosphere, creating a brilliant glowing flash of plasma. In physics, this is called electrical arcing. It looks exactly like miniature lightning bolts shooting off your fork. While a tiny spark might not instantly blow up your entire house, it creates localized bursts of extreme heat that can easily melt the plastic components inside the microwave, permanently destroy the delicate magnetron, or quickly catch your dry food or paper towel on fire. That is why the golden rule remains absolute. Never put anything with sharp metal edges or thin foil inside the chamber. Understanding the brilliant physics humming away inside that little metal box takes all the mystery and fear out of your kitchen. It is not using nuclear radiation or toxic magic. It is just using highly concentrated radio waves to make the water in your food dance until it gets hot, while strictly avoiding sharp metals to prevent microscopic lightning storms. The next time you heat up a midnight snack, you will know exactly how much incredible science is working perfectly to satisfy your cravings. If you found this breakdown helpful and want to discover how more of your everyday household appliances actually work, hit that subscribe button. Give this video a quick thumbs up and leave a comment below telling me the weirdest thing you accidentally left in the microwave. Thanks for watching and stay safe in the kitchen.